So this is our 11th chapter, analysis of variance. Analysis of variance means that we will discuss the difference among the different variances or different means. For example, in chapter 9 we discuss single mean. In chapter 2 we were discussing two means. But how about if we have more than two means? So to discuss the variation among different means, we use analysis of variance. So it has nothing to do with variance. So students normally get confused that we are now discussing variance. No, we are discussing means among different groups. So in this chapter, the basic concept of experimental design, we will discuss the how we use one-way analysis of variance to test the difference among mean of several groups. We will not discuss these two topics. So in analysis of variance, we apply f-test. In analysis of variance, we apply f-test as well. And if f-test accept or reject, on the basis of exception or rejection, we apply Tukey-Kramer's multiple comparison. We will discuss it later. And we later on, we will apply Levene test for homogeneity of variance. We will discuss this one as well. How to do this, we will see it later. So as I said, in analysis of variance, we discuss means among different groups. So here you can see, for instance, an example, the number of accidents for first, second and third shift expected mileage for 5 different brands. And there are assumptions like before, population is normally distributed, population have equal variances, and samples are randomly and independently drawn. As I said, we are discussing means of different groups. So H naught is that all the means of all populations or of all samples are equal, and H1 you don't need to write that they are not equal. You can simply write in words that all means of populations are not equal, so that is fine. And null and alternate hypothesis is like this, and this is your bell-shaped figure that all three means are equal and means of populations are always in the center, and you can say that in H1 not all the means are equal. This is the part of the formula. As I said, we apply f-test, and f-test equals to MSA over MSW. What is MSA and what is MSW? They are coming from this formula. So SST is total sum of squares, SSA sum of squares among groups, and SSW sum of square within groups. So SST is equals to SSA plus SSW, and we further use SSA SSW to calculate f-stats. So total variation is based on the two concepts, variation due to factors or variation due to errors. To calculate SST, this is the general formula to calculate SST. Xij is combination of all the values. For example, we have group 1, group 2 and group 3, and each group have 5 values. 5 values here, 5 values here. So all the values one by one will take deviation from their combined mean. Sum of this, sum of this, sum of this divided by 15, because there are 15 values, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 up till 15. I will explain it in detail how to apply this one. So we can write it in expanded form. All the values will take deviation from their collective mean. X double bar is grand mean. We will see in example how to calculate this grand mean. And this is the formula for SSA. This is how we calculate SSA, like x bar j minus x grand mean and their whole square times number of values in that group. Again, I am saying that I will explain this in detail. Right now you can just have a look of this formula. And this is MSA, which I already told you that f stats is MSA over MSW. So MSA will be calculated through this formula, SSA will come from this formula, and C is number of columns or so-called number of groups minus 1. There were 3 groups, as I said, G1, G2, G3. So C is 3 columns. and this is the formula for SSA. Again, I will explain it in example how to apply this formula. Over there things will be more clear and simple. And this is the formula for SSW. So these are the formulas. You don't need to worry about this. It is very simple and very easy. When you will solve the example, this is just a calculation of different means. You just need to calculate means again and again, and you just need to substitute them into the formula. And this is how we calculate MSW. Again, I'm saying this is the formula, very easy to apply, very easy to apply. I will explain it in upcoming example. So far I am just explaining the process. So in expanded form, SSW can be written in this form. So here it is, MSA equals to this, MSW equals to this, MST equals to this. And next slide you can see FStat is MSA over MSW. MSA is this, MSW is this. We will substitute the values here, and likewise we will take the decision on the basis of F critical. F critical will come from alpha by 2, degree of freedom of 1, and degree of freedom of 2. You know the formula of FStat, like before you have used F statistics formula. Here degree of freedom 1, degree of freedom 2, you can locate the value of F critical, and you can accept or reject on the basis of reject H naught if F stat is greater than F critical. So that is the simple procedure. Now in next PPT I will give you an example.